So yesterday we focused on reducing, multiplying, and dividing rational expressions. Today our focus is going to be on adding and subtracting. And the thing that makes this particularly challenging is that you must have a common denominator. And this was challenging back when you were doing it with regular fractions. Believe it or not, it might still be. But it becomes more challenging as a algebraic exercise. So that's what we're going to be focusing on today. Also, just a reminder, we have this test coming up, so keep your eye on that Friday coming up. So recall, we went to actually adding and subtracting fractions with regular numbers. We wanted to find the lowest common denominator. And you might have gotten to the point where you just kind of look at the two denominators and say, okay, well, what's a number that I can make 6 and 8 become that's low, and I can make them both become 24 by multiplying them. Okay, that's something you could do. But that's pretty intuitive, and you might have had to work your way up to it. If you don't realize what your brain's doing at that point, or maybe your brain's doing something else, the process that you can go through and get the right answer each time is you can factorize your denominators, do a prime factorization. So 6 is 2 times 3, 8 is 2 cubed, and the lowest common denominator is the number that contains all of those factors. So the LCD has to contain 2's and 3's. It has to contain 2 to the highest power that it is listed, and 3 to the highest power that it is listed. You have to go to the highest power that it is listed, or else you won't contain the 8, and you won't contain anything else that's there. So you go to the highest power of each factor. So that would give you an LCD of 24. So really, you have to grab each factor to the highest power. And this is to find the LCD. And so now we know that the LCD is 2 cubed times 3. So therefore, right here, this fraction needs a 2 squared, so it can become 2 cubed. So I'm going to multiply this side by 2 squared on top and bottom. So that can become the LCD of 2 cubed times 3. And then this one needs a 3. So it can have the LCD 2 cubed times 3. And so then I get 4 over 2 cubed times 3 plus 3 over 2 cubed times 3, or 7 over 2 cubed times 3, which is 24. Questions on that? So while some of you might have known that like 5 minutes ago, the same process is done with algebraic expressions. So that's why I wanted to go through it with just regular numbers. Okay? Yeah. If you were doing this, I wouldn't do this. Like, I would just, whatever. Yeah. But we're going to be doing it with algebra, x's, y's, binomials, trinomials. So, like this. So, a little note. If you can reduce your fractions ahead of time, it's likely to help you. before you go ahead and add and subtract them. So for example, in reducing your fractions, if you guys did the homework last night, you know you have to factor the numerator and the denominator. So that is also useful when we're finding the lowest common denominator. When we're doing that, we also have to factorize. So the factoring process is going to be essential when we do all of these rational expression problems. So I'll factorize all of my pieces, numerator, denominator, on all the sides. Then, if I reduce my fractions, it perhaps will help my cause. So here the 5's will cancel, here the x minus 1's will cancel, and then, serendipitously, I get a common denominator. So sometimes it will benefit us to reduce the fractions prior to adding or subtracting. This is one of those cases. So remember, when you add two fractions with a common denominator, the denominator stays common. So it stays x minus 5, and then the numerator, in this case, gets added because it has the plus sign between it. Can we reduce this at all? Cancel out the x's? Good job. You cannot do that. You cannot cancel terms, so don't be tempted. Questions on that? So again, I'm going to factorize. Numerator cannot be factored. That's awesome. Less work for me. Denominator, I can definitely factor that. X minus 2 times x minus 1. Don't forget to factor out your greatest common factors. 2x minus 4 is a binomial, but there's a 2 that can be taken out. If you don't fully factor, you're probably not going to be finding the lowest common denominator. So that's going to make the problem a lot harder for you. So in this case, the LCD, again, you take each factor to the highest power that it is listed. So one factor is x minus 2. Another factor is x minus 1. Another factor is 2. And I'm going to write the 2 in front just because it looks weird in the back. So the 2 comes up once, so I need to take that to the first power. The x minus 2 is just to the first power, so that I list once, and then x minus 1 is also just listed to the first power. So this is my lowest common denominator. So I am going to rewrite both of these fractions with that as the LCD. Some pre-writing here because my goal is to rewrite each fraction with those as the denominators. So this first fraction, the only thing it's missing from the denominator is a 2. So I'm going to multiply top and bottom by 2, making sure to multiply the entire numerator by 2. Then you have a couple of options. You can either multiply it out now or you can do the other fraction. I'm just probably going to multiply it out now so I can distribute. So I get 10x minus 2. So that's the result for my first fraction. My second fraction, when you check out the LCD, it's missing x minus 1. So I'll have to multiply top and bottom by x minus 1. And then I'm going to need to simplify my numerator. The reason the numerators do need to be simplified, in other words, multiplied out, is because you will need to combine all the like terms in the numerator. So my new numerator is 3x minus 3. That is my LCD. So it matches 2 times x minus 2 times x minus 1, 2 times x minus 2 times x minus 1. Now, when you go to add the fractions, you combine the numerators, combining like terms, you're adding. So you get 13x minus 5 over my LCD. 2 times x minus 2 times x minus 1. There is a possibility that you would need to reduce the fraction at this point. But 13x minus 5, this numerator here, is not factorable. It is a prime factor, and that does not cancel out with any of the factors in the denominator. So you are finished. Ashley? Yes, I would not recommend multiplying that out, because if you do anything wrong, I would have to take off points, and so it just opens you up for error. Yeah, so just leave it. Other questions? But you do have to multiply everything out in the numerators, because if you don't, you can't combine like terms. So this one, it's still the same concept. You are subtracting fractions, though. So notice the minus sign here. Generally, you're going to apply the minus sign in the numerator. You can choose to apply it either in the numerator or the denominator, but in this case, my denominator, the lead term is positive right here. This lead term is a positive number, so I don't want to mess with that. So I'm going to apply the negative in my numerator. You don't have to distribute that negative sign right away, but I just don't want to forget about it. Lose track of the fact that I am subtracting this particular binomial. So I'm going to take care of that right now, just for good housekeeping there. Now I will factor each of my denominators so that I can find the LCD. So the first factorization is x minus 3 times x plus 1. The second one is going to be x minus 3 and x plus 2. And then my LCD is just going to be each of those factors. So you have x minus 3, the highest power of that is to the first, so you only need one of them. You only need one x plus 1, and you need one x plus 2, or x plus 2 to the first. Questions so far? Now, to achieve the LCD, I'm going to be multiplying each fraction by one binomial, in this case, to achieve the LCD. So this first fraction is lacking the x plus 2. So I have to multiply that by x plus 2 so it matches the LCD. The second fraction is lacking x plus 1. So that's what I must multiply both the top and the bottom of that fraction by. So now I have to FOIL out my numerator and denominator so then I can combine like terms and then add my fractions. So going down here, I get 5x squared. I get 1x and 10x. Now you don't have to write these out, I'm just doing it for clarity. So that's 11x plus 2 over. Now this is where I'm going to take a couple shortcuts. Instead of rewriting the LCD a ton of times, I'm just going to write LCD. Because here I said LCD, I basically defined it within the problem. So now I'm going to take advantage of that and just say, hey, here's my LCD. But you have to state that that is the LCD so that when you refer to it, you have stated it. You can't not write what it is and then say, oh, I'm saying the LCD. So So you do have to say, this is the LCD, and then you can use it later. Plus, now up here, I'm going to distribute, or in other words, FOIL, negative 5x squared, and then I have 3x and negative 5x, so that's negative 2x plus 3 over my LCD. I'd like to say lastly, but I don't know if it's lastly, because I might have to reduce my fraction. It might be my last step though. I'm going to combine like terms, or in other words, add my numerators. So I get 9x plus 5. Now I can't, in my final answer, say LCD. You have to write it out at this point because you are answering the question now. So no more shortcuts. Because 9x plus 5 is prime, you can't factor that at all. And that factor is not present in the denominator. This is reduced. So that's it. So these problems are a lot because you have to factor so many times. And it's just really important to be neat because losing track of negative signs, it's just there's many ways to get lost. So keep track of what's going on. I love using different colors. That really helps me. I'm a very visual person, so I even, if you are visual, you could use different colors in your notes so they match these notes, and even different colors in your homework. So this problem has an opportunity to become a lot easier. And the opportunity you have is that the two denominators are opposites. One is x minus 4, one is 4 minus x. And if you realize that these are opposites, you can handle that a number of ways. One way, probably the easiest way in my mind to handle it, is I would probably just take the fraction that looks weird, like x minus 4 looks more aesthetically pleasing to me than 4 minus x, just because of doing years and years and years of algebra. I would probably take this second fraction and multiply top and bottom by -1. That is a legal move because you're doing the same thing in the numerator as you are in the denominator. So then I have x plus -3 over, and then you have -4 plus x. -4 plus x is the same as x minus 4. So by multiplying top and bottom by -1, you generate a situation where you have a common denominator. So you no longer have to multiply top and bottom by algebraic factors. You just had to multiply by -1. It just makes for a much cleaner problem. So your final answer would be x minus 3 over x minus 4. Much simpler than multiplying by a binomial. This one is one people get wrong, because they think they have to multiply by 4 minus x for both of them and generate an LCD, which isn't necessary. Okay, so spotting those opposites will save you a lot of time and energy. You see how little work there is really in this problem if you spot the opposites. Okay, questions on that? Okay, so this is where it gets a little hairy. You have 3 fractions. So your LCD must consider all 3 denominators. One thing that's great though is there's no factoring, so that's a benefit. a different factor than x plus 1, which is a different factor than x minus 1. Those are all different. So each fraction needs all three factors. Those are three unique factors. So this will get a little squished when I write it out, but the 2 needs an x plus 1 and an x minus 1. Okay, it's super squished. Maybe I'll just rewrite. I'll use black to indicate what was originally there. So this is what was originally there. And then I had to multiply top and bottom by x plus 1, x minus 1. So the LCD was there. Don't forget it's minus 3, so I'm going to do plus negative 3. The 3 needs an x and an x minus 1. The 5 needs an x and an x plus 1. So again, I was going to try and make it work all in the original problem, but it would have been super squished. So I'm just writing it out. Now you have to multiply everything out. Okay, that's going to be a little time consuming, but you know, just math. So one suggestion I have for you is when you have two binomials here, and you have a regular coefficient, multiply the binomials together first, get that answer, and then distribute in the 2. A lot of people will distribute the 2 more times than is correct. Okay? So if you do the FOIL first and then distribute the 2, or whatever it is, you will always get it right. So x plus 1 times x minus 1 is x squared minus 1. And then if you distribute the 2, you will get 2x squared minus 2. Any questions on that? Okay, and that's over the LCD. Plus. Next one we have, we just have to distribute here, so we get negative 3x squared plus 3x over the LCD, plus 5x squared plus 5x over the LCD equals. Almost there. These are not terribly satisfying, but it's good to be done. You know, that's satisfying. So combining our like terms, we have x squared is a like term. So we have 2x squared, negative 3x squared gives us negative 1, plus 5x squared is 4x squared. And then I have 3x and 5x is 8x, and then minus 2. Over my LCD, which I actually have to write out. And it might be factorable. Then I'm going to try and factor it. You don't seem super excited about it, but I feel like we might need to. So let's just take out a 2 first. So then we get 2x squared plus 4x minus 1. No, maybe it's not factorable. 2 and 2. You said you didn't think it was? Okay, yeah, I agree. Thinking of two numbers and multiply to give you -2, add up to 4, I think I'm at a loss. Okay, so I think, yeah, we're good here. Or you could box that one, either or is good. Questions on that? That's kind of a beast. All odds on both sections.